Hi, I'm Adam Raudonis, and in this space bit, I'm going to talk about the Amazon Remars conference I went to in Las Vegas last month. On day one, I learned that MARS is actually an acronym for Machine Learning, Automation, Robotics, and Space. So there was less space stuff than I expected, but it was still an awesome conference that presented this highly optimistic vision of technology helping to solve all our problems. Whoa! As for space topics, the best session by far was led by Tanya Harrison, who also goes by Tanya of Mars. She started off showing this illustration of just how far away Mars is and how excruciatingly long it takes light to travel there and back, even in the closest approach scenario. So we'll keep this visualization at the bottom, and props to Dr. Donahue for making this video and getting nearly 1 million views of 6 minutes of light traveling across the screen. This distance, along with other deep space missions, leads to some interesting resource contention among the only 3 NASA ground stations that are capable of talking to Mars and beyond. Another trade-off Tanya mentioned comes from Mars Curiosity rover's radioscopic thermal generator. How this RTG works is it charges a battery of limited capacity so that on any given Martian day, you have to choose whether you want to drive or do science. She explained these features of the rover using this augmented reality setup that virtually placed a full-scale model of the rover on stage, so you could walk around it, and after a while, your eyes kind of got used to it, and it felt like it was there. It was really cool. Using gestures to control the arm, she mentioned that the drill bit on Curiosity is actually a modified off-the-shelf one that you could get at somewhere like Home Depot. It's kind of awesome to think that that is on a $2 billion rover now on Mars. Next, she gave a demo where in real time she was able to remotely control a robot in the Canadian Space Agency's Mars yard and drive around for a bit. And you could see segmentation of the different vegetation and neural network-based classification tasks of hazardous soil conditions and obstacles. So it was cool to see that what I'm supporting with autonomous cars could one day be used to help a future mission on Mars. Also at the conference, Jeff Bezos gave a keynote interview where he was asked if there will ever be an Amazon fulfillment center on the moon. Which may sound crazy, but then an actual crazy person rushed onto the stage and asked him to save the chickens. Bezos' company, Blue Origin, brought a mock-up of their New Shepard suborbital capsule, and here you can see my attempt at faking zero gravity. But I also got a chance to talk to some of the software engineers at Blue, working on internal tools, and it was interesting to hear them talk about some of the challenges of convincing the aerospace engineers there to instead use their new web-based design tools. Some more bits from the conference were that the Director of Innovation at the Aerospace Corporation talked about a roadmap for developing cooperating and modular satellites that would come together to form some larger hive structure. The startup Ambidextrous Robotics mentioned they think the robotic grasping problem will be solved within the next 10 years, which opens up the possibility for more human-like helper robots on a mission to Mars. It was cool to see how the Amazon Go stores used pose estimation to figure out where customers are in the store and what they took, and I could imagine this could be used on a long-duration space missions to help astronauts with inventory keeping and hopefully remove that task so they can focus on more high-value ones like doing science. On the expo floor, PT Scientists had a booth. They're a startup based in Berlin that partners with Audi and Vodafone, and they're looking to sell delivery to the moon's surface as a service. And the representative I spoke to there mentioned they already have some payloads under contract, which is pretty awesome. The founder of this 2-month-old company called Astrea spoke about autonomous Martian habitats, but sadly there was not much technical details beyond buzzwords. Instead, I would bet on a company called AI Space Factory, which recently won NASA's 3D printed habitat challenge. Although the speaker did have an interesting tidbit about radiation, how on Earth we receive an average of 0.6 rems of radiation per year, and on Mars that's about 13. But in Ramsar, Iran, due to naturally occurring uranium in the wells nearby, the people receive an average of 15 rems per year, and they don't actually have an increase in cancer rates. Next, an AWS engineer talked about the interesting technical challenges around making radiation-hardened GPUs for AI applications in space. Finally, Keith Volkert, the CEO of Satellite Consulting, analyzed boosting the tons of material in dead geosynchronous satellites to lunar orbit for eventual use in a moon base. He proposed reusing old solar panels, batteries, comms equipment, stepper motors, fuel tanks, structural trusses, and thermal blankets, while recycling aerospace-grade aluminum, steel, titanium, copper, and silver for 3D printing applications. Those are my notes from the conference. Check out the links in the description below, and let me know in the comments if this video was more or less boring than the blob of light crawling across the screen. And remember, click subscribe to get more space bits.